You know, hiding in plain sight in our kitchens, our bathrooms, and garages, there's this silent guardian, a little safety device that most of us, let's be honest, barely ever notice. But this humble little thing is often all that stands between us and a really serious electric shock. Just picture it for a second. You're using a hairdryer. Maybe you're near a sink and something goes wrong. An appliance drops, a wire gets frayed. What is it that prevents a total tragedy in that split second? Well, the answer is an incredible piece of high-speed engineering. And when I say high speed, I really, really mean it. This little device can shut off the power faster than you can blink, in as little as 1/40th of a second. That speed, that's the difference between a little zap and a life-threatening disaster. It's called a ground fault circuit interrupter, or as we all know it, a GFCI. And get this, while it's been a lifesaver for decades, the technology that's inside our walls is actually getting a massive, crucial upgrade to keep up with our modern lives. So let's break down how it all works. Okay, so first things first, let's really get a handle on what this device is and how it pulls off its silent, life-saving duty every single day. At its heart, a GFCI is a safety sensor. Its only job is to constantly watch the electricity flowing through a circuit. It's not looking for big power surges or overloads like a breaker in your main panel. No, it's looking for something way more specific and, honestly, a lot more dangerous to you and me. The way it works is actually pretty brilliant. Just think of a perfectly balanced scale. On one side, you've got all the electricity flowing into whatever you've plugged in, and on the other side, you've got the electricity flowing back out. As long as those two amounts are exactly the same, the scale stays balanced and the power stays on. Simple, right? So here's how it plays out, step by step. First, the GFCI is constantly comparing the current on that hot wire and the neutral wire. Second, it's looking for any imbalance. If even a tiny, tiny fraction of that electricity, we're talking as little as 4 to 6 milliamps, goes missing, it makes a critical assumption. That electricity has found a new, dangerous path to ground, and that path might be through a person. So third, it instantly, and I mean instantly, slams on the brakes and cuts the power. And it does all of that in that mind-boggling 1/40th of a second. That speed is everything because it stops the flow of electricity long before it can do serious damage to your heart or your nervous system. It's just incredible. But, and there's a but, this incredible sensitivity, while it's a lifesaver, has also created a very modern problem, something that electricians call a nuisance trip. It sounds a little weird, doesn't it? How can a safety device possibly be too good at its job? Well, the problem comes up when these GFCIs start, seeing ghosts in the machine. And the culprits are often our newest, most advanced appliances. We're talking about things like EV chargers, modern high-efficiency air conditioners, or even new washing machines. They all use complex electronics, like power inverters and variable speed motors. And as part of their normal, everyday operation, these devices create a kind of harmless electrical chatter or noise on the circuit. Here's a great way to think about it. A real ground fault, a real danger, is like a security alarm going off. It's a clear, urgent signal that something's wrong. But that electrical noise from our new gadgets, that's like loud background music. A standard GFCI, bless its heart, just can't tell the difference. It hears that music, thinks it's the alarm, and shuts the whole party down, even when there's no real danger. And that is a nuisance trip. Thankfully, electrical engineers have come up with a brilliant solution. And it's not about making GFCIs less sensitive to danger. Not at all. It's about making them smarter about what they're listening for. So let me introduce you to the HF-marked GFCI. The HF stands for high frequency. These new devices have advanced filtering technology built right in, and it's specifically designed to tell the difference between the low-frequency signature of a real, dangerous ground fault and that high-frequency chatter coming from our modern electronics. So to finish our little analogy from before, if a standard GFCI is just a microphone that picks up every sound in the room, the new HF-marked GFCI is like a pair of intelligent noise-canceling headphones. It actively filters out all that background music, that harmless appliance chatter, so it can focus only on what really matters, the sound of the actual alarm. Now, this kind of smart protection isn't just for our homes. When you get into bigger industrial-scale jobs where the electrical loads are way higher, you need a whole other class of GFCI. So the standard device in your house is Class A GFCI. But for the heavy-duty stuff, think industrial or big commercial buildings, there's the special purpose GFCI or SP GFCI. The biggest difference, and you can see it right there, is the trip threshold.
While your home GFCI is super sensitive, tripping at just 4 to 6 milliamps, an SP GFCI is designed to allow for up to 20 milliamps of leakage.
So, why the huge difference? Well, it's because heavy industrial machines can actually have a natural, totally non-hazardous leakage current when they're running. It's just part of how they work. An SBGCI is calibrated to ignore that expected normal leakage while still being more than sensitive enough to protect a person from a genuine, dangerous fault.
Okay, so we've got smarter GFCIs for our homes and tougher ones for big industrial jobs. Now, these advancements are actually being written into the rulebook, the National Electrical Code.
And a really key update is coming in the 2026 code. Starting September 1st, 2026, any new outdoor HVAC equipment, think your central air conditioning unit, is going to be required to have GFCI protection. This is a massive step forward for safety.
So, why is this rule just happening now? Well, for years, it was pretty much impossible to do this. A standard GFCI would just constantly trip from all the electrical noise of an AC unit's motors and fans. But now, thanks to those smart HF-marked GFCIs we talked about, the code can finally mandate this critical safety feature without driving homeowners nuts with false alarms.
So what does this all mean for you, like, right now? It means you can take 30 seconds just once a month to make sure your own silent guardians are still on the job. Find each GFCI outlet, push the test button. You should hear a little click and the power should cut out. Then just hit reset to bring it back. If it doesn't trip when you test it, it's time to get it replaced right away.
You know, that quote really says it all. The GFCI is this amazing piece of engineering that works tirelessly in the background. You'll probably never even know it's there, protecting you, protecting your family, until that one critical moment when it does its job in 1/40th of a second. Makes you wonder, what other invisible technologies are keeping us safe every day?